Hello, welcome. This is an introduction to Unit 4, and I'm giving you this brief video to help you along your way as you work through these things. Numbers 1 through 8, these are all multiplication, and you should be able to use your calculator, except for perhaps one of them. But I think you'll get the pattern. Numbers 1 through 8 should go pretty fast. But if we look at the next section where we're talking about solving one and two-step linear equations. We've given an example. How do you solve 4 minus 7x equals 9? And so the first step is to subtract 4 from both sides of the equation. So this minus 4 is the only thing that's different from the original equation. 4 minus 7x on the left and 9 on the right. And so you just added or subtracted -4. And the reason that we did that was because it's the opposite of this 4 right here. And so we subtract 4 to get rid of that 4, and that's why we're left with just minus 7x equals 5. And if we've got minus 7x is equal to 5, then the opposite of negative 7x means negative 7 times x. We want to get the 7 alone. And so we divide both sides by negative 7. And when you simplify that, these get crossed off because the opposite of multiplying by negative 7 is dividing by negative 7. You get 1, and that goes away. And on the right, you get 5 over negative 7, which is just negative 5/7. Then you might also see it written in this way. And this is just a vertical way of doing the same thing. So the opposite of 4 is subtract 4, and we do that to both sides. And then the opposite of multiplying by negative 7, dividing by negative 7, which is the same as we saw it previously. All right. Most of these pretty straightforward. You should be able to do them. That was a two-step equation, but a lot of these are just single-step equations. But if we look at one like number 16, we've got 3/4 times m is equal to 0. And the opposite of multiplying by 3/4 is dividing by 3/4, but you have to do the same thing to both sides. And so that would cancel the 3/4, leaving m alone. And you'd have 0 divided by 3/4. And when you take 0 divided by any other number, you get 0. So m is equal to 0 in that case. Well, let's also take a look at number 19. On number 19, we've got 3k plus 4 is equal to 0. So we want the k to be alone, and so we're going to get rid of everything else it's not with the k. So first get rid of this plus 4 that doesn't have a variable by it. So we do that with the opposite, which is subtract 4, and we do that from both sides of the equal sign. And that cancels the 4, leaving 3k on the left, and 0 minus 4 is -4. And then the opposite of 3k, which is 3 times k, or multiplied by 3, is divide by 3. So we do that to both sides. And that would leave us with k is equal to -4/3. And we just leave our answer as an improper fraction. All right, let's take a look at the back sheet here, where we are asked to simplify radicals. So it says, for example, how do we simplify 882? The square root of 882. And so first we find the prime factorization of 882. Let me cover these up real quick. Sorry. Waiting for my computer to think. Okay, here it comes. All right, just something to cover this up with a little bit. So the prime factorization of 882 says, notice that 882 is even, so it's divisible by 2. Start there. So we do, and we see that 882 divided by 2 is 441. And then 441, as it says here, is not even, so it's not divisible by 2. Try 3 next, it works, so try 3 again. If you're confused about how to do this, just try dividing the number by whatever number you're trying, like in this case 3, and if you get a decimal, then it's not a factor. So 147 divided by 3 is 49. And 49 is not divisible by 3, it's not divisible by 5. The next prime number is 7, so you try 7, and sure enough, 49 divided by 7 is 7. And when you get a prime number at the bottom, you're done. So the prime factors of, so the prime factors of 882 are 2, 3, 3 again, 7, and 7 again. Or 2 times 3 times 3 and 7 times 7. If you multiply those all together, you'll get 882. So the square root of 882 is the same as 2 under the radical, 2, 3 squared, 7 squared. So the 3 squared, the square root of 3 squared comes out as a 3, and the square root of 7 squared comes out as a 7, leaving this 2 that doesn't have a pair still under the radical. And so then you multiply these together, 3 times 7. 3 times 7 is 21, and then you got the square root of 2. So the answer of the square root of 882 is 21 square root of 2. All right, let me do, I'll do a couple here for you again. The square root of 84. So we're going to take 84. I'll just do it off here to the side. 84, and it is even, so divide by 2, goes in 42 times. 42 is still even, so 2 will go into 42 21 times. Now, 21 is not even, so 2 will not go into 21. So I go to 3, and 3 goes into 21. So 3 goes into 21 7 times, and 7 is prime, and so these are the prime factors: 2, 2, 3, and 7. And so I can rewrite the square root of 84 as the square root of 2 times itself 2 times, so that's 2 squared, times 3 times 7. And this 2 squared, which is the 2 times the 2, is the opposite of, like, square root is squaring, and so it undoes each other. And so the square root of 2 squared, 2. 3 and 7 don't have pairs, so they stay under the radical. 3 times 7, and we just multiply them together. 2 times the square root of 21. And that is the square root of 84 simplified. Now you can always put both of these in a calculator to see if they are equal to the same decimal. Let's take a look at number 28. So 28 is simple. This is square root of 8. So let's take a look at what does that look like. 8 is even. 2 goes into 8 4 times. 4 is even, so 2 goes into 4 2 times. So the prime factorization of 8 is 2 times 2 times 2. And I'm not going to write it with the exponents this time because these two 2's right here are going to come out from the radical. They're the same as 2 squared. And so I'm going to bring those out as 2. And this 2 right here doesn't have a pair, and so it stays under the radical, so we get 2 square root of 2, and that is the simplified form of the square root of 8. So work together as you're working through this, help each other out, and do your best. Thank you.